Hello everyone, this question is about trigonometric equations. Solve the equation 2 cos x minus cos 1 half x equals 1 for x is between 0 and 2 pi. So first of all, in the MF19 you have this formula, the cos double angle. So here we use cos 2a equals 2 cos squared a minus 1. And in case you are wondering, why don't we use cos squared minus sine squared or 1 minus 2 sine squared? Well, we can. You're gonna get exactly the same final answer in the end, but instead of cos, you're gonna use tangent, inverse trigonometry tangent in the end. So in case you want to use 2 cos squared minus 1, first of all, because the angle in the question is cos x instead of 2a, if 2a is x, of course the a is supposed to be 1 half x. So that's why we use 2 cos squared 1 half x minus 1. So we replace the cos x with 2 cos squared 1 half x minus 1. So that's the hardest part, I guess. Then we just do the algebra here. We multiply by 2, and then rearrange a little, move it, and move the 1 here to the left. We get minus 1, so minus 3. And then if this is confusing, we can simplify things using the letter a here. So cos 1 half x is a, so we have this quadratic, and then we can factorize the quadratic. We get a minus 1 for a plus 3, which means a can be 1 or minus 3 over 4. So the a is cos 1 half x. To find the 1 half x, we do inverse cos 1, which is 0. So 1 half x is 0, so x is 0. For the minus 3 over 4, first of all, if you look at the domain here, for x, domain is from 0 and 2 pi. Because the angle we are dealing with is 1 half x, we have to divide throughout by 2. So 0 divided by 2, x divided by 2, 2 pi divided by 2. So the domain is only from 0 to pi. So only quadrant 1 or quadrant 2 angles are possible. So since we are looking for negative value of cos, we have to use the quadrant 2 angle. And quadrant 2 angle is pi minus base angle or quadrant 1 angle. And to find the base angle, we have to use inverse cos. So to find base angle, we use inverse trigonometry, but using the positive. So we ignore the negative sign, if any. So we use inverse cos 3 over 4. And after you use a calculator, pi minus inverse cos 3 over 4, you're going to get this number. Notice that we use 5 significant figures here because this is not the final answer. This is just the intermediate working. So we have to use more than 3 SF so that the final answer will be accurate in 3 significant figures. We multiply by 2, and the final answer is in 3 significant figures for angles in radians. That's it. I'll see you again next time.